Hi everyone, welcome to our talk. There's a lot of people in here. We didn't actually expect this many people, did we? No. So hello everyone, welcome to Mobile HTML, the future of your sites.
My name is
You on?
no, the thing is not. My name is Beverloo. I'm a software engineer at Google. I work with Chrome for Android and I mostly specialize in
Yeah, are we?
Okay.
Yay!
Hello? Yeah, this sounds better.
Yay!
So my name is Beverloo. I'm a software engineer at Google. I work on the Chrome for Android team and I mostly specialize in pushing the web platform forward.
Yep, I'm Paul Kinlan, developer advocate on Chrome, specializing in the mobile web, and you can catch me at all these normal places. So should we get started?
Yeah, sounds good.
We should get into it. So it's always good to start with a survey and kind of understand how everyone in this room deals with mobile. So I want everyone to put your hand up if you have a smartphone. Pretty sure that's, yeah, no, keep it up, you gotta keep it up. Right, so who has a 24-inch smartphone? One person has got a 24-inch smartphone. How big? Come on, show it please. Have you got it? No. Sorry? Yeah. I actually, the reason why I'm kind of looking dumbfounded is because I actually realized I forgot to enter the number of the person I'm calling. So who has a dual 24-inch screen? Okay. I've actually designed all these slides for a 24-inch screen.
Yeah, it's a little bit of a bummer.
Yeah, oh man. So who loves typing on a phone? Okay, no one, that's cool. Who has a gigabit Ethernet connected phone? No? Who's got a 5G phone, a 4G phone? A couple of people are getting really fast phones now. It's kind of interesting. And who uses their desktop or their phone as their primary desktop type of device? You know, this is kind of interesting because if you're kind of working out and about and not a developer, this actually is going to be one of those things that happens in the near future where your primary machine actually is your phone. So I know I'm being a bit kind of like facetious with the photos and all this type of stuff, but what we're trying to say is that mobile is different. And the way that we're building our sites and applications at the moment, we're still not targeting this mobile web, which is, if you look at India, for instance, like 60% of the traffic is mobile-based, and we're still not building applications and sites that cater for that.
So probably the most obvious difference between desktop machines and mobile devices is that the screen is significantly smaller. So as developers, we've got less space to play with.
Yeah, and our users are mobile, right? I know the word is mobile, and we're talking about mobile web development, but you know, our users are out and about, and can we take advantage of the fact that they might be in a shopping mall, they might be on the street, they might be driving down the road. They might actually have a state where they don't have a great internet connection, and can we build applications and sites which are responsive to this?
And even though you're the kind of person who likes writing an essay on a mobile phone, I absolutely hate typing on these devices.
Yeah, and most of our sites, or most of our apps at least, or devices, have unique hardware capabilities. Meaning if everyone's phone has a GPS receiver, a camera, and a whole host of other kind of really interesting features that we just don't get on the desktop web. And what can we do to take advantage of that today?
Mm-hmm. And then, of course, everything is slower. On a mobile device, it's not just the screen which is slower, but because the whole device is slower, we actually don't have the space available to put in a big-ass GPU such as we can in a desktop machine.
Yeah.
So in this presentation today, we're going to talk a little bit about features which are available on the web today, which are being developed, and a few features which are still being under development by the standardization institutes, but which are still quite interesting to talk about, and we expect them to be available in the near future. Then we're going to look at six decent mobile browsers, notably Opera for Android, the beta version. And these icons will be displayed on most of the slides, most of the feature slides. And if the logo is colored, then the feature is available. If it's gray and kind of light, then clearly it's not. So the screens on a mobile device are smaller, and this has a number of constraints which it put on us, not just on us developers, but it has constraints on the end user as well. We're used to developing sites from a desktop perspective, and we've got all the screen estate to play with. And on a mobile device, clearly, we need to be more careful. So the first thing to keep in mind is that a browser by default, a mobile browser by default will assume that, that the website you're visiting is a desktop website. This means that it will assume that the width of the web page will be equal to 980 pixels. This kind of varies per browser, but for Chrome for Android it's 980 pixels. The browser does this because desktop websites have been made with a decent width in mind. And if you suddenly decrease the width of that page to be much smaller than it originally was, then the website can completely look distorted, text becomes unreadable, and functionality becomes unavailable. So that's kind of a hack we have to do in order to make the mobile web usable for the vast majority of the website today. Of course, when you're developing a mobile website, this is not what you want. You want the website to have the width of the screen itself, so you don't have horizontal scrolling. And the first thing you should do is add a meta viewport element. The third example shows the complete entry which you should add to the pages. It's actually quite simple. You specify that the width of your viewport should be equal to the width of the device. And you say that the initial scale should be equal to 1, so that the user doesn't have to zoom in before they can read your content. Now, editing a meta tag can be a little bit awkward, and especially if you want to have several meta tags, because your viewport has to be slightly different for a mobile phone or a tablet device, then you probably have to resort to either server-side detection of the device or to JavaScript to change it on the fly, and that's just not cool. So a feature which is currently being developed is called CSS device adaptation, and this adds the add viewport rule to CSS. The add viewport rule exposes exactly the same information as the meta element, but it also allows you to change that information using the declarative syntax which you're used to from CSS. After all, the viewport itself, it's more presentational than it is based on the semantics of your page. So it should be better in CSS anyway. Now, when you combine this with media queries, which is a cool trick allowing you to have different sets of styling based on constraints of the device the user is using to look at your website. You can actually use media queries to have several add viewport rules based on, for example, the width of the device which is being used. Let's look a little bit more about these media queries. They're kind of an old feature. Most of you will probably already have used them in one way or another. But especially for mobile, they're quite important. Now, the most basic example probably is to have different styling rules based on the width of the height of the device. And you can have as many constraints in there as you want, so you can have different styling rules for tablets and phones in its most basic uses. You can select based on the aspect ratio of the device. In the television era, we all remember this. We all remember the change from normal 4:3 televisions to 60:9 widescreen televisions.
I'm still on an old TV.
Yes, you still have an old TV. And because of that, we wanted to display black bars on the television itself. Now, if you have video content on your page, you actually might want to do exactly the same. And probably the most interesting one for today's mobile devices is the resolution directive. The resolution directive allows you to select based on the pixel density of the device. You may already know this using the proprietary WebKit device pixel ratio. And based on that, you can have a good use case for that could be to have different images for high resolution images, such as Apple Retina screens, or the newer Galaxy Nexus devices, or for example, the Galaxy Nexus S4. A small note about the resolution media query. While it's upcoming, it's not yet completely available in all browsers, but the syntax is way less awkward than the old WebKit device pixel ratio. Now, all of these can probably be used on desktop as well, and this presentation, after all, is about mobile. So one directive which is especially interesting for mobile devices is the orientation media query. This allows you to have different styling of the page based on how the user is holding the device, which can change while they're watching your website. Of course, selecting based on the viewport itself is interesting, but it would also be nice if you can size elements or fonts based on the width of the height of the viewport. Because of that, 4 new units are being introduced to CSS. They're called the viewport units. There's VW for the width of the viewport, there's V8 for the height of the viewport, and a Vmin and Vmax, which respectively map to the smallest and the largest value of the two. They work a little bit like percentages, so 100 VW will be equal to the complete width of the viewport. Now, the viewport itself is smaller. We know about that. And on a desktop machine, we probably do have two 24-inch monitors. At least we do, but you'll at least have one. And it's quite likely that content on websites is being displayed next to each other, or, well, often in multiple columns, just because all that screen estate is available. And it's really a shame if you let it go to waste. On a mobile device, this is quite different. You have a lot less space, and content which can be displayed next to each other might actually be more convenient if you display it on top of each other on a mobile device. And the CSS Flexible Box module allows you to do exactly this. It allows you to reorder the content on the fly, reorder it based on putting an element above the other using CSS, or even changing the entire flow of your content. Now, one thing to keep in mind is that the syntax of the Flexible Box module changed recently. And it's a little bit awkward, but you may have to support both the old and the new syntax until enough browsers ship the new syntax. And we all know fixed position elements. They stick around on your viewport, could be useful for like a navigation bar. But fixed position elements have gotten a little brother called sticky positioned elements. These behave like inline inflow elements, just as if they're relatively positioned, unless the parent element partially moves out of view. In that case, the browser will make sure that the sticky positioned element kind of sticks around in the viewport, which is quite a cool feature, which is really useful for, as an example, the address book showed on the slide.
Cool. So we said earlier on that users are mobile, and we're trying to talk about the idea that they might not always have an internet connection. They might be in a place where maybe they're on a train, for instance, where they go through a tunnel and the internet connection dies. And on the mobile web, generally, that experience is pretty bad. So we're going to look at a couple of different technologies that you can use today, pretty much across all of the mobile web, to actually accommodate the fact that your users are mobile. Now, I want to do a little set, who knows the geolocation API? Okay, not actually, I was expecting more people. So anyway, the geolocation API, it's been around on the web for quite a long time now. And it's really good for specializing content, for instance, on news sites where you'll say, well, where is the user? Oh, they're based in the UK. We're going to give them UK-based news. Now, users, well, developers, in fact, always used to use reverse IP lookup. On mobile, that's not as applicable anymore. And especially if you want to get fine-grained control of where the user is and understand where they are, you need an API like the geolocation API. And it's a pretty simple API, get current position, and after a short time, it will basically tell you the user's current location. There's actually an accuracy level as well. And kind of what Android does as well at the moment is it will give you a net location pretty quickly, but it's not hugely accurate. It might be within, say, 100 meters of where the user is. If you want to get a more accurate lock on the user, there's another API called watch position, which actually it does exactly what it says. It watches the user's position whilst they're on that page. And it could be used for situations where you're trying to track the user when they're walking down the street and you can update a map. Or it could just be used to get a finer lock, like a final lock on where the user is. So you, for instance, could say, well, the first request is within 100 meters, and then after a couple of seconds, and you'll probably see from this demo if it actually works, the accuracy level changes, so it goes from, say, an accuracy level of 11 to 10 to 9 to 8. And as it gets more accurate, your position gets more and more close to where the user is.
So if you saw the keynote yesterday morning, in the Android part, they introduced a new version of the Google Play services, and this has a feature called the Fuse Location Provider. And the Fuse Location Provider will actually mean that the phone has a cached position of where the user is. So Get Current Position will be able to more quickly return a more accurate position if you use this new version of the Android Play services.
So you know where the user is, and you're trying to not necessarily track them, but understand where they are so you can adapt your application. Device orientation is another feature that is available pretty much across most of the mobile web. And device orientation, it's a pretty simple API. We saw the CSS before where you could understand whether the user was in portrait or landscape mode. The orientation events basically fire whenever the user moves their phone. So if they're holding their phone this way, you can understand the angle, the pitch, which is the beta property of how they're holding their phone, and you can also understand with a relatively decent level of accuracy their compass location, which is the alpha property, and I think technically it's called yaw. It's pretty well supported across the mobile web, and you can use it today. It's been around for about at least a year and a half. So we know where the user is, and we're trying to help you build applications which are responsive to how they're holding their phone. The biggest problem that we face in the mobile web with regards to users on the move is offline. Now, offline is super important, and if you're an application developer, a native application developer, you've already got offline supported. You build your applications to work offline straight away, then integrate online functionality in. We as web developers, like everything is always online. We go to a URL, we always get it, and it actually is pretty hard to integrate offline functionality into our applications. The first thing that we can do, though, is we can look and understand when the user is either online or offline. Now, it's not entirely accurate. You can understand exactly when they're offline because they have no network connection, basically. But the online state is a little bit more awkward, right? You could be online, you could be on a local network, a Wi-Fi connection, but have no internet connection. So the online event really just basically means that you have a connection to a network. It might not be a connection to the internet. And there's a property that you can watch to see whether you are online or not. And this is great for when you're building an application and the user is going to submit a form. You can just basically say, hey, you can't submit this form, you're offline. So you can provide a nice little bit of feedback there. You go one step further. You understand when the user is online or offline. They go to the URL bar, they press refresh, and then they get this really horrible gateway error or a Chrome error that says, like, hey, no internet connection, you can't do anything. That's a really bad experience, and that's one of the things that's holding the mobile web back. Well, this application cache, this API has been around for quite a long time now. And a lot of people don't like it, and it's got a bit of a bad press. But if you're building an application, which is like a single-page application, this API will help you easily make your application work offline. And it does so by basically listing a whole series of files which encompass your application. It's called the application manifest. And in your HTML, you point to the manifest using the manifest attribute, and the browser will then go off, make sure all the assets are available for offline use, so when you press refresh, you'll still be able to get your application. And I must warn you, right, like there's a whole load of photos of my face entirely through this presentation. Like it's the only one we had rights to, and he didn't want me to do anything with his. So anyway, so that's the application cache. There are a couple of little caveats. If you update any of your assets and then you expect the user to be able to get them, they won't. They need to update the manifest, or you need to update the manifest for them to go and get that data. And if you cache the manifest itself, you're just into a whole heap of pain, because you'll never be able to update the manifest because everyone will always have the manifest. It's a nightmare. Anyway, we have storage APIs, right? We have this idea that our application is going to work offline. And for them to work offline, we need to make sure our data is offline. And we're not actually in a great position, are we, on the mobile web at the moment? We have local storage. Local storage, key value pair system. You can put blobs of data in and strings of data and get them out via a key. And it's ubiquitous. It's on every single platform available. However, you can't really do any rich, powerful querying semantics with it. We have two other APIs, Web SQL database and index database. Web SQL, it's kind of cool. Everyone knows SQL. Hands up if you know SQL. See, any browser vendors in here who said Web SQL is rubbish? Everyone said it's cool. No. So anyway, so Web SQL, everyone knows SQL. It's got rich querying semantics. However, it's not broadly supported. It's not yet, or it's in iOS, Android, and Chrome, but it's not in Firefox. And it's not in Internet Explorer, and it's no plans to be in there. It's a deprecated API. We have index database. Index database is the way that we're going to store data in the web, but it's not really broadly supported. It's not on iOS. It's not on Android. It's in Chrome and the rest of the browsers. So what are you going to do as a developer? Well, the only sane solution that we've got is to use abstractions and use shims. There are a couple of shims out there. Lawnchair has been around for a long, long time, and it's basically a key value pair system with some query semantics, where you can plug in your own custom providers to say, hey, I want to use Web SQL database, or hey, I'm going to use index database. And then there's two others, like Async Storage, which is similar to Lawnchair, and then the index database shim. And the index database shim basically says, you know what, we're going to use the index database API if it's there. If it's not there, we're just going to fall back to Web SQL. And if you have that method where you can fall back from index database to Web SQL, you can cover pretty much all the mobile web for storing offline.
So input on a mobile device is harder. We know this. We don't write essays on a mobile device, and for the major share, they're actually used for consumption of data rather than producing data. Now, this shows when you have a form on your website, even if it's just a login form or a form where a user has to enter a number, it's just awkward to enter it, especially on a mobile device like a phone. You will get this on-screen keyboard, and it's just basically awkward to use. I often click on the wrong letter, and I've learned to rely on the auto correction feature, or even on the suggestions which can be displayed above the keyboard itself, which is something Android does. Now, you've probably heard this a million times already. Use semantical input types. It's quite simple. Instead of using input type as text, you use input type with a more specialized type. A good example of this is using input type as number. If you want the user to enter a number, which could be a telephone number or a price or anything else, you really don't want to have them go through the hassle of seeing letters, characters on their keyboard, having to click on Shift and then finding really small bundles of the numbers. Well, the phone has a perfectly optimized keyboard, just showing numbers. Now, a more extreme example probably is date and time input. I'm from the UK, as is Paul, and date and time, I believe here you write the month first, and then the day, and then the year. For us it's different, for other countries it's different again.
I believe the UK has the correct format.
Do you use dashes to separate the components of a date, or do you use slashes? And really, it's just awkward. And it's not just difficult for the end user using your website, but it's also difficult for you as a developer, because users give all these dates in random input types, and you have to write complicated procedures in your backend to handle all of them. Now, if you would just change that input type as text to input type as date, or even input type datetime local, then the phone will be able to do something really smart and simple. It's actually a no-brainer. It will show you a date and time picker. And by a date and time picker, that makes it infinitely easier to enter a date or time for a site. And it will give you, as a developer, a more consistent result when the user submits that form to the website. Now, this doesn't just result in more convenience for the user. Another additional benefit you get from this is validation, client-side validation of the input type itself. That if the user somehow manages to enter rubbish, the browser will show a dialog about, I don't know what you're doing, but this is not quite what the website will be expecting. You want to correct this. And you can use attributes such as min and max to actually impose a range based on which number or which date can be entered by the end user. Now, when I use my desktop computer, I have this small device next to me, a mouse, and this gives me a cursor on the screen itself, which is incredibly accurate. It's really convenient to use. It allows me to select any element or any position on my screen with really high accuracy. Now, I don't know about you guys, but in comparison to that mouse pointer, my finger is fat. It's really fat. It's inaccurate, and it becomes infinitely harder to click on exactly the point on the screen where I want. And this has forced browsers to implement alternative solutions, such as Chrome's disambiguation pop-up, which basically zooms in on part of the page, allowing you to clarify what you mean, or for Safari to have a number of heuristics available to think what you might want to have clicked on. Now, you can optimize for this. There are 3 primary events available: untouch start, which will be called when you put a finger on the screen; untouch move, when you actually move on the screen; and untouch end, when you remove the finger from the screen again. And this allows you to optimize your application for touch input and maybe have slightly bigger error margins because it's more inaccurate, or have a different UI, different handling altogether based on what the user does with their fingers. Now, there's one thing to keep in mind here. There is a small click delay imposed by the browser. When you tap on the screen itself and remove your finger again, that's a tap. But there's this gesture available in Chrome called double tap to zoom. Now, if you double tap on the screen, it will zoom into that element and the page will not receive a click element. The browser needs a little bit of time to actually figure out whether you want to tap once or tap twice. And before it knows that, it will wait, and after that wait, it will send a click event. Now, 300 milliseconds is quite a long time if you want to have a responsive user interface. It's a number of frames. It's actually 20 frames. That's quite a lot. So you should be really careful with, well, you can avoid this if you set a viewport rule on your page. And the next feature, pointer events, also provides a solution to this. Pointer events is a specification which is still in development, which unifies certain concepts. It unifies the concept of a mouse pointer and touch input, and for example, a stylus, into the concept of a pointer, which really could be anything, without losing too much of the pointer-specific information or constraints. The JavaScript imperative event API is quite similar to what we're used to from mouse events. Instead of mouse in the name, you'll have pointer. And it will create a flow, it will allow you to create a flow in your application to handle both touch input and mouse input using the same code. Now, this specification also comes with a simple CSS property called touch action. And if you specify touch action is none on any element, you will actually tell the browser that if the user taps on exactly that element, that the browser shouldn't do any default action, and thereby the double-click to zoom gesture won't work. And because it won't work, the browser doesn't have to wait 300 milliseconds and can immediately forward that click event to the browser. Quite related, but not specifically part of the pointer event specification, are the pointer directives available for media queries. And by specifying pointer coarse for fingers or pointer fine for mouse pointers, you can actually have different sets of styling based on whether the device the user is viewing your website with is capable of a certain kind of input. Now, you all got pixels. A pixel supports both, so there is a little bit of trickery you have to keep in mind here.
So one quick point. Are we actually implementing this in Chrome? Or?
There was an intent to implement, which we received from Microsoft.
Yeah. But that doesn't mean we're implementing it just yet.
We're implementing parts of it.
Oh, okay, cool. So each of our devices has unique capabilities, such as GPS, a location which we saw earlier for the geolocation API, and cameras and a whole host of other things. What can we take advantage of on the web today, and what is pretty ubiquitous? Well, like 2 years ago, we also spoke about this, and no one seems to be using it, but you can actually take pictures used from the user's phone using a simple input type equals file and put the capture attribute at the top there. And what that essentially indicates to the browser or the user agent is that you should be able to pick whether you're going to take a picture or something from the user's gallery. And I've actually set up my Android device here. Like I said, I'm vain, so there's obviously lots of pictures of me. My Android device here to automatically use the camera. But it's really cool, this API, because it's like a normal input type. If there's no support for the camera there, it'll just let you pick pictures from the gallery. Now, the really cool thing about this is that because it's a DOM element, there's an on-change event which happens, which allows you to get access to the raw data that was delivered from the file system into your application, and then you can manipulate it however you want using the file reader and file writer APIs. The logical extension to this, and the thing that we found from native applications at least anyway, is that developers don't really want to have their applications, and users don't want them either, to have to go out from one application and jump into another application just to take a picture. They want this nice, seamless, integrated experience. Well, part of the WebRTC specification is get user media, and get user media delivers you basically video and audio streams from the user's webcam. Now, the really nice thing about this is you're sitting there going, it's a video stream, it's not really a picture. Well, the code's not in here, and it's inside the demo, but you'll basically be able to take a picture from the camera, the video stream, by just attaching it to a canvas element, and you can take it out from there. So you have integrated access to the user's webcam inside their phone just by using this simple API. It's kind of in Chrome. It's actually in Chrome flags. Hopefully, it'll be enabled pretty soon. But it's actually supported across Firefox and other browsers as well. So it's getting there. It's pretty nice. You can always fall back to the other API. The other one is Android intents, right? If you're building an application for Android, you normally know the Android intent system pretty well. Now, what you normally do is you can communicate between apps by asking for an action that says, well, I need an app that supports sharing, and that's cool. Now, the common thing is we don't really have that on the web anymore, but we have this idea of, well, my Android device supports intents. Can I invoke an intent from the web? Well, you can, and it's supported in the Android browser and the Chrome browser, and it allows us to open applications from our site. So if you've built a native application, you can just basically encode a special URI, which is the intent colon sequence. Make sure your application supports the browsable category, which basically means my application is allowed to be opened by the browser. And any link that has this scheme will be able to open up an application directly inside the user's machine or inside their device. The really cool thing for me on this side of things is the application isn't installed because you have to include the package name of your application. You can actually direct the user automatically to the Android store. And that's a pretty cool and a pretty powerful API to have when you want to get the user to install your native application as well as your by the side of your web-based application. And this demo is just the QR code app. It's not just a normal camera. It's an application that obviously uses the camera, but is dedicated to taking QR codes. And we've integrated with that with just that one line of code inside Android, inside the Android browser in Chrome. Now, one of the cool things about native applications is that your application basically takes up the entire screen. You don't have this horrible, well, it's not horrible URL bar. That's the wrong thing to say. It's like this awkward little URL bar for your applications, normally with a forward and backwards button and a refresh and all this type of stuff. Your application or game takes up the entire screen. Well, this is coming to Chrome as well, but basically we have the actual WebKit request full screen API implemented in Chrome, which allows you to take any DOM element and make it full screen. And this demo here, I've got the ability to take the document, the entire page, or a single element, which is an image, and make it full screen. And there's an API which actually cancels that out, so you can actually back it out pretty easy. The other thing you'll notice on the Chrome browser for Android is that we don't actually yet support scroll to, which is an iOS idiom, basically where you can push the address bar out the way. We don't support it yet. We will do soon in some later builds, at least. That's right, isn't it?
Yep.
Yeah, we will definitely support it. Which means that if you've got an application which tries to push it out the way, it'll work, and you'll have the same experience inside the Chrome for Android browser.
So because a mobile device is much smaller in just in its physical size, and we can't put in all these fancy GPUs and big components, which are actually quite fast, there are a number of limitations. Now, if you've been to the Chrome stand upstairs, we categorize these limitations in 3 categories. Firstly, computational limitations, for example, in JavaScript execution speed. Rendering limitations in fast scrolling or displaying your website in a quick way. But both of these have been covered by a number of other presentations already, and you can definitely go back to YouTube after Google I/O and watch these presentations. We want to look at 2 APIs which are quite relevant to the network aspect of limitations, because the user can be on the move at all time. Let's look at what happens when a user navigates to a new page. Now, this could be because they enter a URL in their address bar, or this could be because they click on a link. When the navigation starts, the first part will be the network. During this network phase, the browser will have to figure out the DNS of your web server, so it will have to change your domain name in an IP address. It will have to say hello to the server, basically, I want resources, are you ready for me? And this takes some time. Now, after this, it will start loading the page. It will start sending messages to the server about exactly which resources it wants, unless, of course, it finds a redirection. When it does so, it restarts a navigation based on exactly the URL which it wants to redirect to. And that's valuable time which is lost. And after it's loading and it got the code of the resource itself, it will start to process the data, and for an HTML file, this could, for example, mean that it starts to build a DOM. Now, there are a number of things which could be slow here, and the only way to really be sure of what is slow is to measure. So the Navigation Timing API exposes a lot of data on all these items, which allow you to, with great accuracy, see what parts of loading the page are taking out a lot of time. And this is actually reflected in DevTools as well. You can open DevTools on any page, and it allows you to see the same in the timeline panel. Now, when I create a website, it's not just a page of HTML which I will be delivering to my users. I will have images, I will have style sheets, I'll probably have JavaScript files as well in some cases. And the Resource Timing API is quite complementary to the Navigation Timing API, except that it contains information about the timing of several resources being loaded by the page instead of just the page itself. This gives you much more high fidelity information about each resource, and it will allow you to quickly identify scripts or just style sheet files which are blocking the loading of your page.
Cool. So we've seen some amazing pictures of my face throughout this entire presentation, and I really do apologize for that. But I kind of highlight some of the newer features that are coming to the web platform. We've seen a lot of things which, basically we've tried to say that the web platform on mobile is just as competent as the desktop platform. But there are a couple of areas where we've been kind of a little bit behind, and I'm going to show you some of these, which are experimental features that are available inside Chrome. The first is obviously the extension to to get user media called WebRTC. Now, a lot of people have heard about this in the sense that you can take one video stream, audio stream, and pass it directly to another phone or another device or another desktop machine without having to proxy it through your own servers. That's cool. That's like the peer connection stuff. That's been on the desktop side of things for a little while. One area that we don't really talk about, but it's actually landed in Chrome and a couple of other browsers, is the data channel. And the data channel allows you to send data directly from one application to another. And there's a talk tomorrow by Sam Dutton, which is going to cover a lot of this area around WebRTC. We can't do it justice today, but it is coming, and you can try it inside Chrome flags today, inside Chrome already. If you're a developer, my recommendation is, I don't really like the API that much, but WebRTC.io and EasyRTC, these APIs, these abstractions on top of it, they work really well and allow you to build these type of applications in just a couple of lines of code. The next is web audio. Games developers have been wanting this for ages because they want to build real-time kind of audio, low-latency audio into their platform. And I'm not going to go into too much again because it's a very long and complex subject, but it gives you near real-time access to the audio streams and the audio data that you can manipulate inside the JavaScript. And this is coming to the mobile platform. Right now, it's only available on, I need to get this right, on devices supporting the Neon chipset, which just kind of luckily happens to be a large number of devices at the moment. And that's one of the reasons why we're still keeping it behind the flags as well, because it's not broadly available just yet, and it still needs some time to bake. And WebGL. This is a demo by the guys at Play Canvas. They built it in about a day or so. But essentially, there's WebGL support inside Opera, I believe, and Firefox, which allows you to build these 3D rich interactive games. And if you combine that with WebRTC and web audio, you can build these really kind of cool collaborative gaming. You name it, you can build it, and it'd be cool. So we are nearly finished now, aren't we?
Yep.
That's pretty cool. We're running close on time. I want to ask one question. Do you want to ask it?
So, is the mobile web awesome yet?
Is it awesome? No, who said no? Oh. There's supposed to be a rally call to, yes, it is. So, we can.
We can adapt to the various screen sizes of mobile devices. We know that screen sizes of mobile devices are smaller, they have limitations, but there's plenty of features available for us to restructure content based on that, or to work around these constraints to bring a proper user experience to your users.
We can accommodate users on the move, the geolocation API, the offline access APIs. We can build applications that are responsive to users being on the move.
We can speed up input. It's awkward, but we can make it as easy for the user as is possible.
And we can integrate with all the device features. You have access to the camera, you have access to GPS, and the whole load of other features that on the mobile web today that are ubiquitous across the platform.
Yep. We can measure exactly where in our applications the pain points are. Now, I know that we just looked at some network and specifications related to the network, but there's a lot we can do to actually figure out why it's slow.
And we can look forward to WebRTC, Web Audio, and WebGL. So I think in summary, we believe that web on the mobile web is absolutely awesome. Thank you very much.
Thank you.
I'm going to say we do have 3 minutes for questions. It's probably best if we take them off stage or outside. Me and Peter will be available for any questions that you do have. Thank you.